Welcome to ECHO 204, Study Session 13, Economic Application of Integration. The usefulness of integral calculus in economics cannot be overemphasized. Some of its applications are presented in this section. Recall that derivative of a total function gives its marginal function. For example, the derivative of total revenue function yields the marginal revenue function. MR equals dTR by dQ. You can reverse the operation by taking the integral of the marginal function to obtain the total function. For example, integral of MR dQ equals integral of dTR by dQ times dQ plus K. Example 1. For a marginal cost function, MC of Q equals 2Q plus 1. Find the total cost function at Q equals 10, assuming that the fixed cost is equal to 10. Solution. TC of Q equals integral of MC dQ, which equals integral of 2Q plus 1, which equals 2Q squared divided by 2 plus Q plus C. TC equals Q squared plus Q plus C, where Q equals 0, TC equals FC. O squared plus O plus C equals 10. C equals 10. Therefore, the total cost function is TC of Q equals Q squared plus Q plus 10. Specifically, total cost when Q equals 10 is obtained as follows. TC equals 10 squared plus 10 plus 10. 100 plus 10 plus 10 equals 120. Example 2. If MPL equals 5L to power 3 is a firm's marginal product, given that labor is the only factor of production, find the firm's production function. Solution. Q equals integral of MPL dQ. Q equals integral of 5L to power 3 dL, which equals 3 over 4 times 5L to power 3 plus C. Q equals 15 over 4 times L to power 3 over 4 plus C. Q equals 0 when L equals 0. Then 0 equals 15 over 4 times 0 raised to power 3 over 4 plus C. Therefore, Q equals 15 over 4 L to power 3 over 4. Definite integral. Definite integral are integrals with limit and boundary. The introduction of boundary helps to eliminate the arbitrary constant. Example 1. Integral of 5x plus 3 in bracket dx within the limit of 0 and 2 equals 5x squared over 2 plus 3x within the limit of 0 and 2 will give us 5 times 2 to power 2 divided by 2 plus 3 of x minus 5 times 0 to power 2 divided by 2 plus 0 times 3, which gives us 10 plus 6 minus 0, which equals 16. Example 2. For a firm with the marginal revenue MR equals 85 minus 5Q, what is the change in the total revenue if it expands its output from 2 to 6? Solution. Integral of 85 minus 5q in bracket dq within the limit of 2 and 6 equals 85q minus 5q squared divided by 2 within the limit of 2 and 6. 85 of 6 minus 5 of 6 squared divided by 2 minus 85 of 2 minus 5 of 2 to power 2 divided by 4 equals 420 minus 160, which equals 260. The solution of definite integral may sometimes involve sketching the graph of the integral. This is only possible where a full polynomial is given. Measuring changes in capital stock also requires the use of definite integral. Example 3. The rate of net investment is I equals 40 t to power 3 over 5, and capital stock at t equals 0 is 75. Find the capital function. K equals the integral of I dt, which equals the integral of 40 t to power 3 over 5 dt, which equals 40 of 5 over 8 t to power 8 over 5 plus c. K equals 25t to power 8 over 5 plus c, where t equals 0 and k equals 75. Then 25 of 0 to power 8 over 5 plus c equals 75. C equals 75. Therefore, k equals 25t to power 8 over 5 plus c, and k equals 25t to power 8 over 5 plus 75. Example 4. The rate of net investment I equals 60t to power 1 over 3, and capital stock at t equals 1 is 85. Find k. Solution. K equals integral of I dt, which equals integral of 60t to power 1 over 3 plus c, which equals 45t to power 4 over 3 plus c. When t equals 1, k equals 85. 45 of 1 to power 4 over 3 plus c equals 85. C equals 85 minus 45, which equals 40. Therefore, k equals 45t to power 4 over 3 plus 40. Consumers and producers surplus. A demand function P1 equals F1 of X. Figure 1 represents the different prices consumers are willing to pay for different quantities of a good. If the equilibrium in the market is at Q0, P0, then the consumers who would be willing to pay more than P0 benefits. Total benefit to consumers is represented by the shaded area and is called consumer surplus. Mathematically, consumer surplus equals integral of F1 of Q dq minus Q0 P0 within the limit of 0 and Q0. A supply function P2 equals F2 of X. Figure 2 represents the different prices at which quantities of a good will be supplied. If a market equilibrium occurs at Q0, P0, the producers who will supply at a lower price than P0 benefit. total gain to producers is called producer surplus and is designated by the shaded area. Mathematically, producer surplus equals Q naught P naught minus integral of F2 of Q dq within the limit of 0 and Q. Example, given the demand function P equals 42 minus 5Q minus Q squared, assuming that the equilibrium price is 6, what is the consumer surplus? Solution. At P naught equals 6, the demand function becomes 42 minus 5Q minus Q squared equals 6. 36 minus 5Q minus Q squared equals 0. Q plus 9 bracket minus Q plus 4 equals 0. Q equals minus 9, Q equals 4. Negative quantity is not feasible, so we neglect minus 9. So Q naught equals 4. Consumer surplus equals integral of bracket 42 minus 5Q minus Q squared dq minus 4 of 6 within the limit of 0 and 4. 42Q minus 5Q squared divided by 2 minus Q to power 3 divided by 3, having an upper limit of 4 and a lower limit of 0, minus 24. Practice exercise. Solve the following. A, integral of x square root of 3x squared plus 5 dx. B,